So the first thing I'm going to talk about is what this word means. Quadratic equation is an equation, obviously, in the form ax squared plus bx plus c equals 0. Quadratic equation. The quadratic will always have an x squared. We've done linear equations, mx plus b. In a linear equation, your x is to the first power. In a quadratic equation, your x is to the second power, all right? So you have ax squared is your thing that actually makes it a quadratic. The rest of it is just in standard form. So in standard form, you would want it just like anything in standard form, your highest exponent, then go down from there with your constant being last. That is standard form, all right? And they'd say where a, b, and c are all real numbers, and the only one that cannot be 0 is the one with the x squared. If the one with the x squared is 0, then you're going to move to a linear equation, because then you're just going to have an x to the first power as your highest one. 0 property product. You already know this rule. You just may not have called it this. Anything times 0 equals 0. So if you have two numbers multiplied together and their product equals 0, this rule says at least one of them has to be a 0. That's the only way you can multiply and get 0 as your answer. All right. And so we're going to use this to solve these equations. All right. The way you solve these is you do the same process we did on the section before. We are going to factor. Okay. And so we are going to do the factoring exactly like we did. We're going to look at this last guy. We need factors of negative 24 that add up to give us a positive 2. Because this guy is negative, we know one's going to be positive and one is going to be negative. So we're really looking at the difference between the two. And so if you go through these 1 and 24, 2 and 12, right, and you keep going through these 3 and 8, you're going to get to 4 and 6. And you're going to say, oh, well, 4 and 6 will multiply to give me 24 and subtract to give me 2. That's what I'm looking for. All right. Specifically, I want a positive 2. So if I want a positive 2, then my 6, my larger factor, has to be positive, and my smaller factor, the 4, would have to be negative. And you can double check this. You can say, well, 6 times negative 4 is negative 24. 6 plus negative 4 is positive 2. I did my factoring correctly. All right. Now you'll notice this guy equals 0. In order to multiply two things, which is what we are doing with these two binomials, this means one of those has to be equal to 0. That's just the rule. You can't multiply two numbers and get 0 unless one of them is 0. And so the way we figure out what makes this a solution is we are going to set each one of these equal to 0 and solve. I'm going to say x plus 6 equals 0. And I'm going to say x minus 4 equals 0. And then I'm just going to solve it. Minus 6. So x is going to equal negative 6 or positive 4. Those are my two solutions for this equation. You can plug it back in and check it. You could plug in a negative 6. So we could say negative 6 squared plus 2 times negative 6 minus 24 equals 0. You're going to get 36 minus 12 minus 24 equals 0. You will see that is true. Okay, and so you can plug these back in and solve. If you want to make sure that you got the right answer, you can check your work. It gives you a list of how do you do this. The first thing is you want to make sure it's in standard form. Squared, then the x, then the constant. You also have to make sure that it is equal to 0. All right, the whole process of factoring says they equal 0. So if you have a number on the other side, or if they're on different sides, move everything to one side so that you have all of your terms on one side and 0 on the other. Okay, and then you are going to just factor and set each factor equal to 0 and then solve, and you are done. Let's look at some other ones, and then I'm going to have you do it. This is an example where it is not in standard form yet. So you'll see that I have the 3x squared and the 6 here and a negative 11x here. I want to move that over. All right. And so I am going to move it over just by adding it over, just like you do. The 11x does not combine with anything, so I'm just going to list it in standard form. 3x squared plus 11x plus 6. Now I have it equal to 0 in standard form. I am going to do my factoring just like I did in my prior section. All right, so for this one, I'm going to do the method where I multiply across. Positive 3 times positive 6 is 18. I am going to look for factors of 18 that add up to give me 11. What are those factors? 92. Yeah, so I have these factors. Add up to give me 11, multiply to give me 18. I am going to rewrite this using those factors. So I'm going to leave the 3x squared alone. I am going to rewrite the 11x using these. So I'm going to say a positive 2x and a positive 9x. And then I'm going to leave this guy alone. So all I've done is I've taken my trinomial and I've rewritten the middle term to break it up into 2. All right? And now I'm just going to use my method factor by grouping. So I'm going to group the first 2. I'm going to group the second 2. My common factor here is an x, and I have 3x plus 2 left over. Common factor in my second group is a 3. I have 3x plus 2 left over. And then, of course, now I have the group itself in common. 3x plus 2. What's left over is the x plus 3. And I have factored it. Since I am solving, I am not done yet. All I've done is factored it. Now I need to set each factor equal to 0. And so I'm going to take those two factors. I am going to set them equal to 0 and solve. So I will say 3x plus 2 equals 0, x plus 3 equals 0, and then go through the process of solving it. Subtract your 2. 3x equals negative 2. Divide by 3. X is going to equal negative 2/3. And then on the other side, it's much simpler. You're just going to subtract your 3. X can also equal negative 3. And once again, I have two answers here. Negative 2/3 and negative 3. Those are my answers. All right. Once again, it is not in standard form. I need to move everything to one side. So I'm going to move this 8x over by just subtraction. Because that's a squared and an x, they do not combine. So I have negative 6x squared minus 8x on this side, and I have 0 on that side. What do 6 and 8 have in common? 2. And I actually, since they're both negative here, oh, that's a positive 6. Okay, good. I was about to say, if that was negative, that's a pain. So we have a 2 in common. What about my variables? What can I take out? Just an x, because that's all the 8 can give me. All right, so 6 divided by 2 is 3. I took out one of my x's. 8 divided by 2 is 4. I took out both of my x's. And now I'm going to set each factor equal to 0. This is a factor. In fact, it's called my greatest common factor. That's what we did at the very beginning of the last section, was just take out your common factor. So I'm going to set that equal to 0. And I'm going to set this one equal to 0 as well. And then we have simple solving. Divide by 2. 0 divided by 2 is a number, okay? It's not a no solution. 0 divided by 2 is 0. It throws a lot of people, but that is an answer. On the other side, add your 4, and then divide by your 3. So it can also equal 4/3. These would be my two answers here, 0 and 4/3. This next example actually does the opposite. So they have been giving us the quadratic, and they want us to find what x equals. This one is actually telling us what x equals, and they want us to give them the quadratic. All right, and so you're basically just going to say x equals. And so you're going to say, well, x equals -1/2 and x equals 3. Now remember, your factors are set equal to 0. And so what you're basically going to do is you are going to get the side that has the number as a 0. So I'm going to start by multiplying this guy by 2. That will get rid of my denominator, and I have 2x equals -1. And then I am going to add the 1 over. And so I have 2x plus 1 equals 0. That means that one of my factors had to be 2x plus 1. All right. And then I'm going to do the same thing over here. I'm going to say, well, I need a 0 over there. And so I have x minus 3 equals 0, which means another factor had to be x minus 3. They want the quadratic. All right. They want the quadratic. So if they want the quadratic, I have to multiply it. I'm actually working backwards. They have given me the answers. They now want the equation. And so I'm going to FOIL, just like I did in the very first section. 2x times x, 2x times -3, 1 times x, and 1 times -3. And then, of course, I need to combine these middle terms. 2x squared minus 5x minus 3 equals 0. So they gave me the answers, and I worked my way back to the quadratic equation. All right. And so there actually will be times when we do this. You can have largers. This is technically not a quadratic at this point because we have it cubed. But when we start factoring, you're going to see that we have a quadratic. When you have something like this, you're actually going to have 3 answers. You'll notice that your degree or your highest exponent is 3. And so we're going to end up with 3 answers for this one. We still want to move everything to one side, so I'm going to move this 14x over. I have 5x cubed plus 3x squared minus 14x equals 0. I still want to look for a common factor. What's in common to all 3 of those? 1, and then what about the variables? An x. And so if I take that x out, you're going to see that you now have a quadratic. All right. And again, you can multiply across just like we would 70 factors of 70 that add up to 3 and keep factoring. But when you do this, you are going to end up with an x. You're going to end up, when you factor this, 5x minus 7, x plus 2, when you do your factoring. And so when it looks like this, you're going to end up with 3. You're going to set the x equal to 0. You're going to set the 5x minus 7 equal to 0, and the x plus 2 equal to 0. And so when it looks like, hey, I can't really do the factoring, make sure you always check to see if there's a common factor first. All right, that common factor coming out first is going to maybe help you do the rest of your factoring. All right, because when you just see the cubed, you might get thrown off and think you cannot do a factoring there, but you can because there's a common factor.